shows the state of equilibrium. When forces are at equilibrium, we are saying the net force acting on the object is 0. So the forces cancel out each other. Therefore, the strings T1, T2, and T3 are joined at point O. The weight of the block is suspended from T3 is 2000. So we have the weight. This is the weight going down. Weight always point downwards. So it's our T3.
Yes.
Then we're going to we have this one, which is our T2. We have this one, which is our T1. So you can do this. I want to show you something. You can extend this one. This is T2x, right? The component of T2 parallel to the
Yes.
surface. So this one is called T2y. Is that clear?
Yes, sir.
So here the angle is 70. Here is 20. Nah? So that it can make 90 degrees. Nah?
Yes, sir.
Or if you don't want to do that, nah, you can just shift that T3. T3, you can draw T3 at this position here. And it's pointing downwards.
Yes.
It's T3. So the angle between T3 and T2 is 20 degrees.
Okay.
Okay. Therefore, we're going to start with T3, of course. Let me draw it here. We start with T3. This is T3. And this is T1. T1 is going to the left. Né? And this
Yes.
is T2.
T2.
So we said the angle between T2 and T3 is what? It's 20. Né? Yes. Yes, 20. Yes, 70. This one is a closed vector diagram. A closed vector. Can you see? We are using tail to head method. Tail to head method. So it's a closed vector diagram. And you must indicate the angles. You can see they said indicate 2 angles. So by doing that, you have drawn the closed vector diagram. You have drawn the closed vector diagram. Is that clear?
Yes, sir.
Okay. Now, let us look at this one here. The first question, it was, what is the difference between a scalar and a vector? So a scalar, what is a scalar?
It is a physical quantity with only magnitude.
Only magnitude. What about a vector?
A physical quantity with both magnitude and direction.
Both magnitude and direction, right? So what is the resultant force acting on the block? Because it's not moving, Fnet is equals to what?
0 newtons.
0 newtons. The resistance forces are at equilibrium. Ne?
Yes.
Are at equilibrium. Now, so the next question says, determine by means of calculation the magnitude of the force T1, T2, and T3. So we're going to use this diagram here. That is why it's very much important to know how to draw a closed vector diagram. Ne?
Yes.
So for us to answer this question, we're going to use this diagram and correlate with the trig ratios. We know the trig ratios. Ne?
Yes, sir.
So we have T3. T3 is given is 2000 newtons. So if we need T2, we can use sine of 70. Ne? Sine of 70 is over hypotenuse. You know that, ne? T3 over T2. I mean, sine of 70 is opposite over hypotenuse. Our hypotenuse is T2. Our opposite is T3.
Okay.
From grade 10 is trig ratio. Sine is opposite over hypotenuse. Tan is opposite over adjacent. Cos is adjacent over hypotenuse. Hypotenuse is the longest side. Ne?
Yes.
Okay. Now we need T2. Remember T3 is given. So T2 is equals to 2000, which is T3
2000.
over sine 70. And you press the calculator and give us the answer.
Okay. 2000 over sine 70. 21. Okay. 2128. Sir, please wait a minute. I'll be back.
Okay, no
Please, please.
problem. Lele 2,
Sorry, sir. Sorry, sir.
are you back?
Yes. Sorry.
No
It's
problem.
2000. Okay. Comma. 36. 36.
36 newtons. If every force is in newtons. Yeah. All forces are in newtons.
Yes.
Okay. Let us look at T2. T3 is just
T1.
2000. Yeah, T1, yeah.
We can finish
T3
one in
is,
2 ways.
yes, we can do it in 2 ways. We can even use the cos of 20. Ne?
Yes.
If we use cos of 20, we will
We
find
can
T2.
also use
Pythagoras for T1, right? Yes. We can use Pythagoras for T1. Okay. T2, T1 is can we use cos of 70?
Yes.
Cos of 7, not cos of 70, but cos. Can we use tan of 70? Sorry, I want to use something that we. Cos of tan. I want us to use tan. Tan of 70 is opposite, which is T3, ne? Over
Yes.
adjacent, which is T1. So T1 is 2000 over tan 70, which is equals to 2000 over tan 70 is equals to what?
Okay. 2000 over 1070. 727. 727. 27.
comma,
27, sir. Comma
comma,
94. 94 newtons.
newtons. So this is our T1. So we have T1, we have T2, we have T3. Né?
Yes.
As long as you can draw a closed vector diagram, with this question, you get everything. Because you're going to apply trig ratio. Né? Always, and usually they will give you the weight. And that T3 is the same as the weight of this object.
Okay. Okay.
T3 is the same as the weight of this object. So always, or
Okay.
usually, let me not say always, they will give you the weight of the object. So once you have the weight, you can use trig ratio to find these other forces. No?
Okay, sir.
Yeah. Let me show you something very much important on Newton's laws. You know what? Newton's laws is not difficult as long as you know how to identify the forces acting on an object. Nah?
Yes.
So let me just show you some important cases here. Once you know these cases, then you cannot go wrong. You cannot. You cannot go wrong. You can never go wrong. Okay? After doing this before I forget. Newton's first law. This is Newton's first law. Newton's first law state that an object will remain in its state of rest or motion at constant velocity unless the non-zero net force acts on it. Nah? So it deals with forces at equilibrium. Newton's first law. So for Newton's first law, Fnet is equals to 0, nah? Because forces are at equilibrium, right?
Okay.
The object will be moving at constant
Velocity.
velocity. That is why it says an object will remain in its state of rest or motion. So acceleration is 0, which will imply that Fnet is 0. Okay, now Newton's second law, an important law. That is what I want to show you. This is first law. So example of first law, before I go for that one, is inertia. Inertia, this is the quantitative measure of mass of an object. The quantitative measure of the mass of an object is inertia. Depend on mass. Let me say depend on mass. The greater the mass, the greater is inertia. So it is when, okay, do you use a bus when you go to school?
Sir?
Do you use a bus when you go to school, or just walk, or use private taxi, or what when you go to school?
I don't use a taxi.
Just walk, just a walking distance.
Yes.
Okay, but sometimes you also take a taxi to the town, right?
Yes.
Okay, so when you are inside the taxi driver, you know, these guys, they're troublesome. They just apply the brakes. Whenever they see a customer, brakes. What happens to you as a passenger? You move forward, né?
Yes.
That moving forward is inertia. You are resisting the change, right, of the motion. Because the change, the taxi driver is applying the backwards motion now. When you are still moving forward, that is why when you are in the car and the car is moving at 260 kilometers per hour and sudden brakes are applied to the car, you will continue to move forward at that 260 kilometers per hour. That is Newton's first law. Ne?
Okay.
Yeah. And you must also look at the issue of seat belt. Ne? You can just read through that. So there's nothing much there. So Newton's second law. Newton's second law. For second law, Fnet is equals to ma. Fnet is not zero here. Ne? Fnet is equals to ma. So the only thing that Elena must know here, of course, is the definition, acceleration, directly proportional to the net force, acceleration inversely proportional to the mass. So this is the relationship that we can deduce, and this is the relationship or it can be written in this form. This is the relationship. Ne? So here is the gradient of this graph is mass. Ne?
Okay.
Gradient here is 1 over F net. Is that clear?
Yes, sir.
The gradient is 1 over, I believe it's 1 over F. Let me check it out. Because we are saying change in A over 1 over change in M. Therefore, this is going to be change in M, change in A. Gradient is F net. Because F, M, and A, the product is what is F net. Ne?
Can I ask why,
Yes.
sir? Why is the
Yes.
acceleration inversely proportional to the mass?
Inversely proportional.
Yes.
So what happens is that as the mass increase of an object, it's not easy for that object to move fast. So like Chibumba, you know Chibumba, a fat guy.
Yeah. No.
Yeah, and slender, you know slender. Ne? The slender will run very fast than the Chibumba one, the fat one. You understand? So
Yes,
that
sir.
one, their masses are the determining factor of their acceleration. So that is why we are saying, okay, because I have a greater mass, then my acceleration will be smaller. But when I have a smaller mass, I'm going to have the greatest acceleration. That is the relationship. But when you look at the force itself, as you increase the force on an object, the object will then increase its acceleration.
Yes, sir.
Therefore, they are directly proportional. That is why that statement says the acceleration is directly proportional to the net force and inversely proportional to the mass of an object. It's clear, né?
Yes, sir.
That's okay. Now let us look at the following. I want to verify the gradient here. Né? We are saying change in A over change in Fnet. So yeah, this is the one which is 1 over mass. It's 1 over mass. It's not the mass, ne? It's not the mass. So you must know this. This is an experiment. So which experiment are you doing this term?
I think we'll be doing Newton's first law and second. Newton's laws, I think so.
It must be Newton's second law. It must be Newton's second. This is the one that will be proving. Believe me, you will do this one. Okay. Let us look at this one. Let us look at this one. Let us look at this one. Yeah, we have to. You have to know this relationship here. The frictional force, ne? The frictional force is divided into two. It's divided into kinetic
And static.
and static. Therefore, this one is the opposition of a moving object, ne? And
Yes.
this one of a stationary object. So Fk here is mu k multiplied by normal, and F, we say F max here, ne? It's mu k multiplied by normal. So N is normal force, ne?
Tiny.
That is what I want us to look at. This one is mu s, sorry, it's not mu k for this one. It's mu s. The coefficient of friction is unitless. Do you know why?
No.
Because it's the ratio of forces. Is the ratio of forces. So we are saying that this mu s or mu k, ne,
Yes, sir.
is equals to Fk, or that one here F over normal. This is newtons, this is newtons, ne? Newtons
Yes,
and
sir.
newtons will cancel out, ne?
Yes.
We end up having no units. So it's unitless. And this thing range between 0, mu s or k, and 1. It range between this. If you are asked to calculate this and you don't get the answer between this, then you are incorrect.
Why can't it be greater than 1?
That is the coefficient, is the coefficient of friction. The coefficient of friction is always less than 1. It's always less than 1. There is no way in which the surface can give us the coefficient or the friction which is greater than 1, which is greater than multiple multiplied by 1. There's no way. It's always less than 1. It's always less than 1. It's due to the surface, and it depends on the surface, right? It depends on the surface. Okay, let us look at this concept of normal force. It's a very important concept, normal force. I will also share the video that I did some time back where I was explaining this concept of normal force. Normal force, actually, let me just define Fnet. I want us to define Fnet on this object. This is the force applied on the object. So the first thing that I will show you is to draw the free body diagram. Né?
Yes, sir.
Here's the normal force. Here's the weight. Here's the applied force. I'm assuming that the object is moving. Né?
Yes, sir.
So our Fnet here, we define Fnet along forces acting parallel to the surface. Né?
Okay.
Then Fnet is equals to MA. Then is F applied minus Fk, which is equals to MA. But let us look at normal force. Normal force in this case, check normal force. Né? Normal force, these forces are always at equilibrium. Therefore, normal force is equals to weight, which is equals to mg. Can you see that?
Yes.
Okay, now this is number one. Let me show you another one. I want to change the way a force is applied. Suppose a force is now applied. Yes.
Sir.
Yes.
The first formula, okay. The first equation is either a standard formula.
Yes, F net is equals to ma. That is the formula né, for Newton's second law. Okay. Then we want to define F net. What F net is, can be represented by these forces, which is applied force and frictional force. These are the forces acting on that block.
Yes.
So let me show you a case whereby we have an object, a force is applied in this fashion at an angle theta. So the surface is still rough. I want us to draw the free body diagram showing all forces acting on the block. We have this force, weight, we have this force, normal. We also have this force, frictional force, I will say Fk. We have this force, this is the F. This is the F. Now, we need to define Fnet, showing all forces acting on the block. Fnet is equals to Ma. Now, let us identify the forces now. Can you see this F? We are not allowed to say F minus Fk. This is very wrong.
Yes.
Because F and Fk, they are not collinear. We cannot add them or subtract them. And another thing that you must always remember is that Fk is or Fs is always in the negative. Né?
Okay.
Because this force is at an angle, it has components. So do you still remember these components I did show you last time?
Yes.
Fx and Fy. Fx and Fy.
Yes.
Therefore, if you can see that we can have our Fnet along these forces, right?
Yes.
Now our Fnet is given by Fx minus Fk is equals to Ma. Fx, remember, is F cos of theta. Né? Must always remember that. But let us do normal force. Normal force plus Fy is equals to W. Can you deduce that?
Yes. Yes. Yes.
Normal force plus Xy is equals to W. Okay. Then how do we define normal? If we have something like this, normal is equals to weight minus Fy. Ne? This is mg minus F sine of theta. Very much important. Very much. If you miss how to define normal force, so you cannot define Fnet. You cannot define Fnet correctly. Is that clear?
Yes, sir.
Okay. Now, let me show you how to define normal force in another different scenario. In another different scenario. I'm still on horizontal plane. I will also show you the inclined plane.
Okay.
Let us
Sir,
have, yes.
do non-collinear forces always form a closed vector diagram? Non-collinear forces
They form a closed vector diagram.
always.
Yes, because they will be at a sort of equilibrium, like so, like these forces. Ne? We have our fx, so they will only form a closed vector diagram ne? When the object is moving at constant velocity or when the object is at rest. Ne? Because if not so, then we're going to have something like this. This is our vector. So you see, we have tail here, meaning that this thing is not at equilibrium.
Yes.
Yeah. They will only form that when it's at rest, not moving.
If
Now,
ever you're not told the sir,
yes,
if ever you're not told that the object is at rest, how will you know the answer?
if the object is not at rest, it simply means that it's moving. If they don't tell you that it's at rest, the object is moving. For rest, for constant velocity, they will have to say it. If they don't say anything about that, then the object is moving. It's moving, but not at constant velocity. The constant velocity, the rest, they will mention it in the statement. And remember, this is grade 11, but examinable at grade 12. If you go to grade 12, you check question 2 of all physics papers, you will find this question. Okay, now I want us to look at the pushing force. Over a rough surface. Let us draw the free body diagram. We have this force, which is what? Weight. Nah? We have this force, normal. We have friction there. We have our F applied. Our F applied is at an angle, therefore it has components. We have FAX and FAY. Let us define Fnet. We define Fnet along forces parallel to the surface or that are collinear to the parallel to the surface. Our Fnet in this case is equals to ma, which is FAX minus FK is equals to MA. Ne? So
yes, sir.
Normal force here. Normal force, can you see that normal force is weight plus FAY?
Yes.
Therefore, this is mg plus F sine of theta. Can you see that it's changing? The normal force is changing.
Yes.
We started with normal force equals to weight, right? Because the force is applied parallel to the surface.
Yes.
Then we move to normal force equals to weight minus Fy. The pulling force is applied at an angle. Then now we have this normal force as weight plus S weight plus. I hope it's clear, ne?
Yes, sir, yes.
Okay, before I can show you a situation whereby we deal with inclined plane, let me just show you for two objects, ne? On the horizontal surface. What do we do with the two objects? As to calculate acceleration, as to calculate anything. Let us have F at an angle. I will only show you this one. So we have A and B. So let us draw the free body diagram. So the surface is rough, ne?
Yes.
If it's not mentioned or is frictionless, the surface is rough. Tension, the force that holds the two objects together is called tension, ne?
Yes, sir.
Fk, of course, this is Fka. Then on B,
Can you please
normal
define
force. Come again.
Can you please define tension first?
Tension is the force that connects the two objects.
Okay.
It's the force in a rope, ne? That connects the two objects. Then we have
Okay.
weight, we have F applied there. We have Fk, and we also have tension. So this is the force acting on B. Now, you can see F is applied at an angle. We have Fx here and Fy here. So let us define Fnet. Fnet is equals to Ma. On this one is T minus Fka is Ma. Ne? On the other one is Fx minus Fk minus T is equals to Ma. Can you see we have two equations here? Ne? After you do your substitution, right, you are going to say equation 1 plus equation 2. Equation 1 plus equation 2. Here we use elimination method. So let me just have the equations here and show you how we deal with this. T minus Fka is equals to Ma. Fx minus Fk minus T is equals to Ma. Of course, the Ma, this one is MB, FKB. So when we add the two equations, right, check. Tension and tension will cancel out, right? Can you see that? We are going to end up having Fx minus Fka minus Fkb is equals to Ma plus Mb to A. Then we can calculate acceleration. We can calculate any other thing depending on the question that you are given. Huh? Is that clear? Is that clear?
No, sir.
Let's
Please explain again.
Okay, so here it's a situation whereby maybe you are given two objects. So the examiner asks you to calculate acceleration. Let me take acceleration for instance. So what you are going to do, even if you are not asked to calculate acceleration, you're asked to calculate either frictional force or whatever. So you are going to use two blocks. You define Fnet on block A, you define Fnet on block B. After doing that, so you are going to have your two equations, equation 1 and equation number 2. In these equations, you will have at least two variables that you don't know. Another one is usually tension. So when you add the two equations, you must just use elimination method. You are adding equation 1 and equation 2. These are the equations.
Yes.
So T and T will cancel out. Can you see that? Because T on the other equation is positive, on the other equation is negative. And it's always like that. Your T on one equation must be positive, on another equation must be negative.
Yes, sir. Yes.
Yeah. Then after that, you have your Fx there. You have your negative FKA. You have your negative FKB. You have your MA there. You have your MB there. A is the same. Acceleration is the same. These two objects will be moving at the same acceleration.
Yes, sir.
Yeah, so then you can calculate the acceleration. You can calculate anything depending on what you are given. Depending on what you are given. Okay. So can I show you inclined plane?
Yes,
The
sir.
inclined plane one, because here I'm giving you a medicine. So you must just administer the medicine.
Yes, sir.
Yeah. You must just administer the medicine. Then you cannot go wrong once you administer this medicine. Okay. Let us look at the inclined plane. Inclined plane. When we talk of inclined plane, we are talking about a plane like this. Let me have this. So inclined plane. This is the inclined plane. I will just use this one, applied force, and I will also use this one. The object is just sliding down.
Yes.
So it's moving up and it's sliding down. So on an inclined plane, the gravitational force has components. Okay, let me just draw the free body diagram so that you can see how to draw the free body diagram. So on an inclined plane, normal force doesn't point upwards. And if you check, normal force was just pointing up, 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 up. Normal force was just pointing up. But here, normal force is not going to point up because normal force is a force that the surface exerts on an object and x in contact with and x perpendicular to the surface. So as a result, this force for this one is going to be like this. Is this force not
Yes.
perpendicular to the surface?
It is, sir.
It is perpendicular to the surface. So we're going to have FG. FG is always point downwards, right? And we have our applied force here, which is parallel to the surface. Now, on an inclined plane, FG has components. We have this component, which is called FG parallel. And we have this component, which is always against the normal force or opposite to the normal force. And our theta is here. So this is our components of FG. How do we define these components? FG parallel. We have FG parallel, which is mg sine of theta. FG perpendicular, mg cos of theta. So you must always remember this when we are dealing with inclined plane. Huh?
Yes, sir.
Okay, so now let us define Fnet. We define Fnet only on the forces acting parallel to the surface, right? But we also have friction here. Forgot
Yes,
to
sir.
indicate the frictional force because we are not told that the surface is frictionless. So the forces acting parallel to the surface are these forces. Therefore, Fnet is equals to MA. This is F applied minus FG parallel
G.
minus FK is equals to MA. This is how we define Fnet. No?
Yes, sir.
On the other block, so let us indicate the normal force first. This is the normal force acting perpendicular to the surface. No?
Yes.
Then this is the weight, Fg, the weight of an object. And here we're going to have, because this object is sliding down, we're going to have frictional force in this direction. Then let us add the components of Fg. We have this component which is always opposite to the normal force, which is Fg perpendicular. We have this one which always point downwards, which is Fg parallel. So our theta is here. Our theta is always between Fg perpendicular and Fg. Ne? Therefore, let us define
Yes, sir.
Fnet. Fnet is MA. Fnet, we're going to say Fg parallel
F.
minus Fk is equals to MA. Ne? We don't have
Okay.
applied
Yes,
force for
sir.
a sliding object. So this is our Fnet. But normal force, how do we define normal force? Normal force on an inclined plane is equals to Fg perpendicular, which is mg cos of theta. Ne?
Yes, sir.
So even if we have two objects on an inclined plane, the same applies. Ne?
Yes, sir.
The same applies. Okay, let me just do one problem. Let me just do one problem for you to show you how we apply this. Ne? I can take it from so maybe before I can do one problem, I forgot something. The issue of a table case. Ne? Let me quickly show you the table case. table case. I call it table case because it has to do with a table. So suppose we have a situation like this. This one is a table. So we have an object here. Ne? I will just assume that a force is applied. We have another object here, AB. So the surface, of course, is rough. Now, I want us to draw the free body diagram on A and also on B. On A, this is the free body diagram. Strictly normal.
Gravitation.
Weight, tension, friction, F applied. So on B, it's only two forces, ne? Tension and weight. There is no normal force on an object that is just hanging, ne?
Yes.
Because normal force, an object must be in contact with the surface.
The surface.
So defining Fnet here, of course, we're going to add the components. Fx
Don't
here.
we have an, sir?
Yes.
Isn't there the air resistance?
Air resistance, we ignore air resistance, ne?
Okay.
Yeah, you will see, the examiner will say ignore air resistance. And the sideway movement. So Fnet is equals to MA. We're going to have Fx minus T minus Fk is equals to MA.
Minus.
So
Yes.
on B, Fnet is equals to MA is T minus what? WB, ne?
Yes.
It's equal to MA. So if you want to calculate acceleration, you just add the two equations. Tension and tension will cancel out, ne?
Yes.
Yeah, it's the same thing, same thing. So this is what
Can
I
you
wanted to show.
acceleration?
Come again.
Can you please calculate the acceleration?
Okay. Yeah, if I was to calculate the acceleration, this is what I'm going to do. I'm going to add equation number 1. Let me say this is number 1 and this number 2. So equation number 1 plus equation number 2. So I'm going to have Fx, oh my God, Fx minus T minus Fk. Then I'm adding everything. B is equals to MA plus MB to the A. Ne? Then T and T will cancel out. So I'm left with Fx minus Fk minus weight B is MA MBA. Then I'm going to divide by that. Ne?
Yes.
Yeah, so this is how I calculate acceleration. It's the same thing. Same thing, same thing, same thing. So you know what I've given you today? I've given you the key to answer question number 2 at grade 12. Or question number 4. I think it's question 4 at grade 11, if not 3. But this is a key, a key. It unlock every question. Unlock every. Let me just show you one example. Ne? Let me just show you one example. And now, just after you, I'm going to teach grade 11. If you feel like you want to join, you can just join. Ne? It's okay. Let me.
Come again.
I mean, just immediately after you now. Now, I was supposed to have started with the other group, yeah, grade 11. So I'm saying I will be doing these Newton's laws. Ne? If you feel you want to join, you can. You can join. Ne?
After. Okay.
That's after you. Maybe after I'm done with this problem that I want to show you, I will just do one problem. Ne? Only
Yes.
one problem. That's it. Let me see if this one. I just want simple problem.
Sir,
Yes.
don't you have a
Come again.
Sir,
Yes.
don't you have a textbook in your cell phone, a physical science grade 11 book?
The one that I have is, I think it's only Siyavula.
I already have that one.
I think it's only, I think I only have Siyavula. I don't have any other textbook.
Okay.
Oh, I have another one I will share with you. Yeah, I remember I have quantum physics. Yeah, quantum physics. So let me just use the table case. Nah? I'm using the table case as an example. I believe that it has the question to calculate acceleration. Yeah. Let us do this one. Let us do this one. Now, this question, it says that a block of mass 2 kg on a rough horizontal surface is connected to another block of mass 1,2 kg by means of a light inaccessible string. The string that connects the two blocks is hanging over a frictionless pulley as shown in the diagram below. So you can see that on 4 kg, 25 newtons is applied. Né? The 4
Yes,
kg block experiences a constant kinetic friction of 2,5 when a force of 25 newtons is applied horizontally. Calculate the magnitude of acceleration of the blocks. Now, we're going to define Fnet. That's it. We define Fnet. We are doing it this way. Fnet is equals to MA. Né? So on 4 kg, how do we define Fnet? We have F applied there. Is F minus T minus Fk is equals to Ma, which is 25.
Yes.
T is not given. Fk is given, is 2,5. M is 4A. So what is 25 minus 2,5? It's 22,5. Ne?
Yes.
This is equation number 1. Then we are done. Let us move to that other block of 1,2. On 1,2 kg, we have tension minus weight. Those are the only forces acting. Ne?
Sir,
Yes.
the addition of 25 and 2,5 is 27,5. 27
We're saying 25 minus 2,5. It's minus. Ne?
minus. Oh, okay.
Yeah, it's minus. It's minus. And then it's F minus Fk.
Okay, okay.
Yeah. So T minus that one. Weight is mg, ne?
Yes.
1,2 multiplied by 9,8. What is 1,2 multiplied by 9,8?
1,2 times 9,8 is 11,76. 11,76.
This is equation number 2. So the next thing that we're going to do is to add the two equations, right?
Yes.
1 plus 2. So we add what is on the left with what is on the right. Ne? 25,5 minus T plus T minus 11,76 is equals to 4 plus 1,2a. Ne? Then what is 25,5 minus 11,76? Yes.
Isn't it supposed to be? I can't see where you got the 25,5 from. 25,5.
25,5 is this one. Come, let us come here up here. Let me change the color to this one. You see these two?
Yes.
25 It's 22, not 25. I wrote 25 here, ne?
Okay, yeah.
22, not 25.
I
22.5, ne?
yeah, I said.
22.5 minus 11.76. What will be the answer?
4 plus 1,2 e 4 plus 1,2.
That one is
It's
5.2, ne?
5,2.
And 22.5 minus 11.76. These two.
22,5 minus 11,76. 10,74.
10.74, ne?
Yes.
And we're going to divide by 5.2, ne? Our A is equals to
10,24. 74.
divided by 5.2.
5,2. The answer is 2, 2,07. 07 meters per
0.07
second squared.
meters per second
Yes.
squared. That is the acceleration. That is the acceleration. So this is how it is done. Can you see where we use two equations to calculate the acceleration? So the next question, quickly let us move to the next question. 5.2, calculate the coefficient of kinetic friction on 4 kg block. So we are given the frictional force, ne?
Yes.
So this is Fk is given is 2.5. Mu k is what we are looking for. The N is the normal force, which is mg in this case, ne?
Yes, sir.
That is 4 multiplied by 9.8. Therefore, mu k is equals 2.5 divided by 4 multiplied by 9.8 is
So
0.
how did you get the normal force, sir?
Huh?
How did you get the normal force?
Okay, yeah, let me. You see, when I was showing you how to define normal force in that first case, when I say normal force is
Yes.
equals to g,
Fg, yeah.
this is our normal force, ne? And this is
Yes.
our Fg. So normal force is equals to Fg, which is equals to mg.
Oh, okay. Yes.
Then in this case, in the not everywhere, I did show you in different cases, ne? In this one,
Yes, sir.
it's mg. Now, and then we need the coefficient of friction. We are given the kinetic frictional force of 2.5. So we need mu k. This one is mg, right?
Yes.
2.5 mu k. M, what is the mass? Is
4 times 9,
9.8.
okay.
So the answer is going to be 0, something.
8.
4.5 divided by what? 4 multiplied by
Okay.
9.8.
Wait. Okay, this 2,5 divided by this 0,06.
0.06.
0,06. Yes.
And there is no SI unit, ne?
Yes, sir.
No SI unit because the ratio of forces. Then we have the second last, which is Newton's third law. So for Newton's third law, guys, that's a statement, ne? Which said that when object A exerts a force on object B simultaneously exert an equal force on A, but in opposite direction. That is Newton's third law. So identify why
Can you
when
please
action,
write down,
the statement.
sir?
Come again.
Can you please write it down?
Oh,
Can you
okay.
please write it?
but in opposite direction.
It's more like a
But
tension force.
yes, you see tension. Tension, yeah, it's sort of an example of Newton's third law. It's action reaction. For every action, there is a reaction. If someone
Yes.
shout at you, you shout at that person back. It's Newton's third law. It's
Okay.
Newton's third law. So it also applies with the universal law of gravity. So when
Yes.
object A exerts a force on object B, object B will exert equal force on object A. It applies almost in most of the cases, right? Like here, if you are asked, like, identify where one action reaction on 4 kg, action reaction is F by table on block and F by block on table. Is the force that the table exert on the block, which is normal force, is going up, and the force that the block exert on the table, which is Fg. You can say it's normal and Fg.
So it's more like you asked to give an example of a Newton's third law of motion.
Yes, that is the answer to 5.4.
Okay.
Yeah, action, reaction. For every action, there is a reaction. Okay, so let us stop here for now because I have to rush to another lesson.
I'll send you the pictures of the activities.
Yes, you must do that. Especially the one for the test. I will send you another one. Especially the one
Okay.
for the test. I did only one question. I will also send you another test. I think I have. They are true. I think they are true. I will send them to you.
Please also send the book to me.
Yes, I will do so.
Okay. Goodbye,
Thank
sir.
you. Bye.